Bolaunter class, normal stack, introduction, and use of ordinary stack. Click Editor S, H, tick to find stack and find normal stack to create a new stack file. After editing the name, click OK. Click on the yellow arrow on the right to go to the stack parameter setting page. The coordinate position here is set to the center point of the first product. We can use the offset and to set the offset in the X, Y, and Z directions. The space here refers to the difference between the center points of two workpieces. Set the space and number. The robot system will automatically calculate the path. The space setting method of the X and Y directions is the same. Both are input the center space of the first and second products. The space in the Z direction refers to the height of the product, and the count here refers to the number of stacking layers. We can choose the stacking direction of X, Y, and Z below. TP means stacking from the starting point of the first workpiece in the X plus or Y plus direction in sequence. RP means stacking in the X or Y direction in sequence. Z direction is set according to the on-site situation. If it's stacking, select PP, and if it's unstacking, select RP. On the right, we can select the sequence. Please note that set X, Y first here, and finally Z. When setting Z first, if the items are not flat enough, there may be interference or collapse after stacking them high. The counter here we can select self-counter, or create a new counter binding in the counter. Their differences are, self-counter can only function as a pure counter. The new counter can perform some condition judgment jumps. Select the run together for the run sequence. If there are special needs, you can also select Final X, Final Y, or Final Z. After setting it, save the parameters we just set and we can use this stacking parameter. Now, based on the previous learning, I will write a program that starts with untacking and ends with stacking. Click Editor S, H, and select the extent in the right bottom. First, switch the coordinate system to the tool coordinates and insert into the program. Click on the workbench pop-up option and switch the workbench to the one corresponding to our operation. After setting up, we can operate in this workbench coordinate system. Create a new flag, convenient for subsequent condition judgment jump. Here we need to set, unstack and then stack, so we need to establish a corresponding counter. Counters are named as Chi and Ma respectively. We handling 8 workpieces here. Input target value 8. And move the robot to the packing transition point. Set and insert current point as the transition point. For material retrieval, move the robot suction cup to the center position of the first workpiece. In order to make the robot walk in a straight line, to pick up parts, there will use relative. So we set the first point of the stack above the workpiece, and use the relative to move straight line to pick it up. After setting it, the coordinates here are the center position coordinates of the first workpiece. The center space of the demonstration workpiece is 50 millimeters, so we input 50. Both the X and Y directions are 2 pieces. Z direction is 2 layers. According to the position of the first workpiece, to select the directions of X, Y, here is going in the X plus and Y plus directions. So the direction 0 and 1 we select the PP. The robot is to unstack first, so the direction to we select our P. We will select the Chi and Duo counter we just established. Click Save and tick Use Stack. Insert the edited stack file into the program. Based on this coordinate, perform relative function to pick the piece. Remember the current Z-axis coordinates. Then move the robot to the workpiece. Calculate the distance between 2 points, and input the numerical value. Click to save, then insert. Now insert a signal of suction cup on. Insert another relative function to allow the robot to pick up the item and move vertically upwards. Next, move the robot to the stacking transition point and repeat the previous operation. Move the robot to the stacking point of the first workpiece. create a new stack file and also use relative function to allow the robot to stacking materials. So we set the upper point as the center point of the first stacking workpiece. Click Insert. This operation is stacking, so change the direction to 2pp. And the counter, select Stack Counter. Other settings remain unchanged. Stack to use stack. Select the stack file we just edited and insert. And insert the relative value of the robot from this point to the stacking point. Then output an instruction for the suction cup OFF and insert a program in relative function to up the robot. Under the palletizing program, insert the corresponding set counter. Then we insert to condition jumps at the end of the program. Jump back to flag 0 when the counter is less than the target value. Finally, click on the data command to insert a control stop instruction. Stop the robot after its stack. This complete program of first unstacking and then stacking is completed. Turn to auto state to run this program. The robot will start stacking from the first point we set up. First, move the workpiece in the X direction. Then move the workpiece in the Y direction. And finally move the workpiece in the Z direction. When the counter reaches 8 counts, it will jump to stop running. Above is the Bull-Lounter class, normal stack, introduction, and use of ordinary stack. Any questions about the content? Welcome to ask questions in the comments. Follow me for more technical information.